Good afternoon, everybody. My name is Lewis Whitcomb, and I'm here today to welcome you to the Department of Mechanical Engineering online open house for fall 2018. We'll start off with an introduction to Johns Hopkins Engineering, and then we'll discuss with you our graduate programs in mechanical engineering, talk about the admissions process, important dates, discuss our research areas in the Department of Mechanical Engineering. We'll share some information regarding student life. We have two real live graduate students to speak to you this afternoon, and we'll end with a live question and answer section. If you have any questions at any point in the presentation, please type them into the questions tab in the control panel. If you're on a cell phone or tablet, select the question mark to access the question section, and we'll address all questions at the end of the presentation, but feel free to type them in real time so we get them in queue. So let me introduce the people who are going to meet today. I'm Lewis Whitcomb. I'm a professor of mechanical engineering and a former department chair. My areas of interest are robotics, navigation and control. I specifically focus on underwater robotics for oceanography and also space robotics. Two of our graduate students who are here today are Gianna Valentino. She's a PhD student with her areas of interest include small-scale mechanical testing, MEMS in extreme environments, and thin films and nanotwin metals. And the second graduate student who's with us here today is Andrew Spielvogel. His area of interest are autonomous underwater vehicles, precision navigation of autonomous underwater vehicles for oceanographic science, and nonlinear systems theory, state estimation, and control systems. So I'd like to give you the overview of the presentation today. First is why Johns Hopkins University? Why should you care? Second, program overview of mechanical engineering, our research areas, and then we're going to review the admissions process in mechanical engineering for our master's and PhD students, and then I'm going to hand everything over to Gianna and Andrew, and they'll relate some of their experience as students here, and then we'll have a Q&A session. So, engineering at JHU. Hopkins is known probably most widely for its School of Medicine, and it's a giant research organization. We have the largest research portfolio of any university in the United States, and we have had that for the last 38 years. So we're almost twice the size of the next largest program in terms of research dollars. The School of Engineering. The School of Engineering has 25 research centers and institutes, and we have 9 different departments. Students and faculty in the School of Engineering collaborate with JHU's other divisions, including the School of Medicine, the Bloomberg School of Public Health, the Applied Physics Laboratory, the School of Nursing, and other divisions. And our expertise in the School of Engineering is very broad, and it includes diverse things such as robotics and human-machine interactions, engineering and biology and medicine, computational data science, and dozens of other disciplines across the School of Engineering. Our mission is to provide an outstanding engineering education that's both rigorous and relevant to 21st century leadership. Our resources for graduate students include the Career Center, employer networking, the Whitey School of Engineering alumni, and resources for entrepreneurship. A number of our students are doing startup companies these days and spinning them out of the university. So a little program overview of the things that we do in mechanical engineering. Mechanical engineering is one of the oldest engineering disciplines at Johns Hopkins University, and we do pioneering in 4 broad areas, and I'll break that down in a little finer detail in a moment. Our broad areas include robotics modeling and control and human-robot interaction, fluid mechanics and thermal processes, mechanics of materials, and mechanics in biology and medicine. Right now, we have 27 full-time faculty. We have about 120 PhD students and about 60 master's students. And I'd like to show a little video that we created that highlights some of our research areas.
Universities that are truly at the top of the chain tend to be known not only for their research, but also for other things such as the impact on the discipline. This is an institution that really sets the state of the art.
I make microfluidic devices that can be very useful for developing personalized medicine. I'm a tool developer, and that's the core that mechanical engineers can provide. We know how to design, how things move, how to make it more efficient.
Currently, we have funding from the Air Force to look at how to control flows over aircraft wings using computer simulation software. But we are able to take those same simulation tools and apply that to understand how blood clots form in the heart, how birds fly, how insects move about.
These are interesting materials that not a lot of people know how to characterize and model, and that's what we do, is we figure out how they work by developing new techniques to study the mechanics of the eye.
We're interested in trying to develop a more scientific fundamental understanding of what we call our human haptic perception or our human touch perception. If you're interested in the medical robotics field, I would say that Hopkins actually can't be beat.
I was really interested in coming to Hopkins because of its very large interdisciplinary action. Not only do you work inside the department, you work outside the department, and even far-reaching to companies and research institutions. When you work in industry, you have to be able to talk to the average person as well as the scientific person, which I don't think as a graduate student I really appreciated until I had to do both.
I really wanted a program that came to the intersection of mechanics and computing. I run my code on supercomputers, and when it's parallelized, it can run on hundreds of thousands of processors.
What sets us apart is our ability to apply these tools to a wide variety of problems and also take advantage of the incredible opportunities for collaboration that exist in a place like Johns Hopkins. Any research project that you can think of and you're looking for a collaborator, there's a good chance that you'll find the world's expert in that topic right here in Hopkins.
My student will learn a lot of experimental skills, but in addition to that, they will interact with my collaborating doctors so that they understand the real problem that they have to tackle when they establish their career.
I'm interested in the control and navigation of underwater robotics, specifically autonomous vehicles. Hopkins provides world-class facilities like our Hydro Lab, which has a 42,000-gallon tank in the JHU ROV, along with close collaborations with the Woods Hole Oceanographic Institution.
Coming to Johns Hopkins has allowed me to kind of take my career in any direction, whether I want to work in academia, go to industry, or maybe a national lab. I have all of those opportunities, and I've been able to work with someone in every one of those disciplines to kind of get a feel for what I want to do.
I work very closely with my students. We meet every week. They'll get a lot of personal attention and a lot of guidance and mentorship. I usually know the ins and outs of their work in the beginning. Later on, they'll know much more than I will.
I chose Hopkins primarily for my advisor. I felt like establishing that bond and establishing, what seemed like a pretty close-knit research group was key towards my academic and graduate career.
Very quickly, students become the leaders on these projects, the thought leaders on these projects. And that's the kind of environment that we try to foster here.
Johns Hopkins has set me up to be successful in terms of my career, academically, as well as in real-world experience.
I anticipate that there's going to be a lot of things happening here in the future, and I think it's being exciting to be a part of that.
Okay, this is Lewis Whitcomb. We're back at the ME Department's Fall 2018 information session. We put a little effort into the video to try to highlight some of our research areas and some of the most important things in the department, which is our graduate students. The video highlighted 4 broad research areas. If you want to be more specific, I'd say that we really have 7 different research areas. The first one near and dear to my heart is robotics and system modeling and control. You can see I made this list. It shows the ordering. However, we have a 100-year tradition in mechanics of materials and micro nanoscale science and engineering. We have a number of faculty members who work in mechanical engineering and biology and medicine, and they work in problems of mechanical engineering and biology and medicine, everything from the molecular and cellular level all the way up to the organism level. And so that's probably 5 orders of magnitude in size, 6 orders of magnitude in size, and very broad research area there. There's a significant amount of collaboration with the School of Medicine in this area, and also with the Kennedy Krieger Institute down at the School of Medicine. We've got a number of faculty members who are working on alternative energy and the environment, including wind energy and energy harvested from the ocean, and network distribution systems for the power grid. And we have a very long tradition of research and teaching in fluid mechanics and heat transfer and thermal processes. The PhD program requirements, let's see, a PhD student will normally, if they come in with a bachelor's degree, will normally complete in 5 to 6 years. If they come in with a master's degree, probably a little bit shorter, 4 or 5 years. PhD requirements include 12 semester courses, and there's 2 exams, a departmental qualifying exam, which is normally taken after 2 or 3 terms of study, and a graduate board oral exam, which is normally taken after about 5 terms of study. And then you have to write a dissertation, and you have to present it, and that's called a thesis defense, and that's the final requirement for the PhD program. And our master's program typically takes students who come from other institutions 3 to 4 semesters to complete. We're on the semester system, so that's 1.5 to 2 years. And all MSc students take 8 courses. 2 of the courses have to be in applied math, numerical analysis, or computational methods. And then there's 2 additional. Then there's 1 additional requirement. If you want to complete a master's degree with just pure coursework, then you have to take 2 additional courses for a total of 10 courses. Or if you're interested in doing a master's thesis, you need to knock on doors and find a master's thesis advisor who will advise you in a project that's of your interest. And you complete 8 courses and a master's thesis as the degree requirements. Same degree, but different requirements depending on whether you want to do a thesis or no thesis. I'd like to tell you a little bit about admissions to our 2 programs. For the PhD program, the average incoming GPA is above 3.8. Our students come in with really incredible GRE scores, 600 plus or 160 plus on the revised test. Quantitative reasoning, 780 plus or 163 plus on the revised test. Analytical writing, 5.5 or above. The main teaching language here at Johns Hopkins University is English, and so we require a TOEFL score of 100 or over on the internet-based test, and the IELTS score equal to 7. All of our PhD students are offered full-time financial aid. A number of our students are able to get external fellowships of their own, and I guess that's pretty much it for the profile of the PhD students in admissions. And I can answer any additional questions that you have in the question and answer session. For our master's students, GPA typically is 3.7 or above. Quite high GRE scores, 540 or above. Verbal, quantitative, 770 or above. Analytical, 5 and above. And same requirements for the TOEFL score or the IELTS. In the admissions process for our graduate programs, the application deadline is December 15th if you want to matriculate in fall of 2019. And the application requirements are you need to complete an online application, you need to write a statement of purpose, you need to provide at least 3 letters of recommendation, you need to have the GRE, send us your GRE scores, and you need to send us your TOEFL language scores, and transcripts from your undergraduate and if you have a master's degree, master's institutions. And the timeline for the review of applications is that after the deadline of December 15th, the faculty review all applications, and at the end of January, the admissions committee makes final decisions and offers of admissions are emailed. For the MSc program, after December 15th, the faculty start reviewing applications, and people are notified typically in mid-February via email. So I'd like to hand this over so that Andrew and Gianna can tell you a little bit about their experience as graduate students here, a little bit about what they did before Hopkins and what brought them here, and what they're doing in their research, and where they expect to go after their PhD. And they'll also tell you a little bit about life in Baltimore. So,
Hi, I'm Gianna Valentino. I am in my 5th year of my PhD, and I'm in the area of mechanics and materials in the mechanical engineering department. I started my career at Hopkins in fall 2014. I came directly from my undergrad, so I have a bachelor's in physics, so I actually switched disciplines, which is not nearly as hard as you might think. And I work with Professor Kevin Hemker, and my area of interest is nanotwined metals, specifically metals that we could take and make them in thin film form and bring those more into extreme environments. So some of the pictures I have here just to show the incredible strength we get from the material I'm working with, which is actually 3 times that of high strength steel. So my PhD thesis is really focused on understanding the interactions of these nanotwin materials and how we can use them in everyday life.
Hi, my name is Andrew Spielvogel, and I'm a 5th year PhD student as well, and I'll talk about my experience before and during Hopkins. I graduated in 2013 from Harvard with a degree in electrical engineering, and then I took a year off and worked for a robotics startup outside of Boston at Harvest Automation, working with autonomous agricultural robots. After a year working there, I was interested in doing more work with autonomous vehicles and interested in transitioning to the underwater robotics world. And that's the primary reason of why I was interested in Hopkins is because my advisor, Lewis Wickham, is one of the leaders in the field for underwater robotics. And so that was my primary reason for applying to Hopkins, along with their very good academics and research facilities. At Hopkins, I primarily have been working on adaptive bias and attitude observers for true north gyro compass systems. So we're trying to create a compass using high-end inertial measurement units without using magnetometers for determining heading. So we're not using magnetic north. We're using Earth's rotation to find north. And one of the special opportunities that from Hopkins was that I was able to deploy this system this past summer off of the Atlantic Explorer using the Century vehicle, where we went on a 2-week scientific cruise off of Bermuda.
Jana and Andrew, would you like to say a little bit about some of the student organizations that you've been involved in?
Yeah, so one of the biggest organizations we have here in the department is MEGA, Mechanical Engineering Graduate Student Association. Andrew actually had been president for a couple of those years, and we both participate heavily in there. And it's student-run, and it's supported through the graduate representative organizations called the GRO, as well as the ME faculty contribute to the MEGA as well. So we host various social events throughout the semester, and each lab also hosts some lab social events to try to intermingle maybe robotics and materials like Andrew and myself, and the bio and the fluids people as well. And those are all throughout campus. Some of them are off campus as well. There's Society of Women Engineers, which obviously is pretty much what it sounds like. Has a bunch of women engineers, tries to empower women in science, since if you look around, it's usually an underpopulated minority here. There's also National Society of Black Engineers and various other organizations. I don't know if you have anything else to say about organization-wise.
So I used to be a member of the graduate representative organization. So every other week, so twice a month, a representative from every department meets from the entire Homewood campus. So I don't know how many. There's something like 40 representatives that meet and discuss different issues and initiatives that are happening on campus to try to get the word out. And also the GRO is in charge of $200,000 where they can give grants to different societies, groups, or even just individuals that want to go do something fun and interesting with their friends. And you just submit a proposal and you can get money from them.
And so these organizations occur sort of different scales. The Mechanical Engineering Graduate Students Association is for mechanical engineering graduate students, masters and graduate students. The Society of Women Engineers and the Women of Lighting, for example, are associations for women engineers in the School of Engineering. and the graduate research organization includes poets and historians and physicists and mathematicians as well as engineers from all across the university. Would Andrew Giano, would you like to share some of your experiences of life in Baltimore?
So for Baltimore, I would say that it's a very good graduate student city because in Hopkins pays you well. Our stipends are good, and the price of living is cost of living is pretty low. Rent is cheap, food is cheap, and there's a lot of fun things to do in the city. There are many neighborhoods that have a lot of fun bars, restaurants, different arts, concerts, and we're also located very close to different hiking areas, close to DC, close to New York. So there are a lot of different opportunities to both go out and have fun on the weekend or escape the city and go out into the outdoors.
Yeah, I think one of the good things about Hopkins is it's pretty centrally located in Baltimore, and there's also good access to public transportation. So you don't necessarily have to have a car to get around Baltimore and to get around campus. A lot of students tend to live around campus just for the ease of commuting, so you can roll out of bed and show up to class. But both Andrew and myself actually live a little bit off campus in more distinct neighborhoods. So this is Charles Village. The neighborhoods closest are Hamden, Mount Vernon, some Fells Point area. They all have different feels, different restaurants, activities that you can do. Definitely art's a big one in Baltimore. And like Andrew said, you can go to pretty much any major city on the East Coast from here. So New York, there's a bus that leaves really close from here, and it's very cheap. You can get it if you book early for under $20. DC, as well as Philadelphia, and pretty much anywhere else you want to go. You're also pretty close to BWI Airport. It's probably only 20-25 minutes from here. So getting around Baltimore is pretty easy, and Hopkins is pretty centrally located.
Okay, thank you. So students often ask, where do our alumni go? Our PhD graduates really go to sort of in three different directions. A number of our graduates are going into industry, where they work for leading companies such as Amazon, Deloitte, General Motors, Google, Hansen, and Think Robotics, Toyota, on and on. A number of our students who want to do research will go on to work for government research labs, and recent PhD graduates have worked at various Department of Defense laboratories, the Food and Drug Administration, the Applied Physics Laboratory, the National Institutes of Health, and other organizations. And a significant number of our PhD graduates go on to become faculty members at top universities around the world. Recent PhD graduates who are faculty members at other universities are faculty members at places such as Brigham and Women's Hospital, Carnegie Mellon, Columbia, Georgia Tech, Harvard, Stanford, UCLA, Stony Brook, University of California, University of Pennsylvania, University of Massachusetts, and other places. So our PhD graduate students really we're populating the world's corporate, government, and research labs and faculty positions with our PhD graduates. Our master's graduates typically go on to one of three next steps. A number of our masters view the master's degree as their destination degree, and they'll go on to industry with top companies around the world or government research labs. And probably a third or more of our master's students go on to PhD programs, and they typically go to top 10, top 15 PhD programs around the world. So that's it for our formal presentation. We wanted to keep it short to about a half an hour, and now we're Gianna, Andrew, and I, and also Mike Bernard, who's our academic program manager, is just joined us, and we're available to answer any questions that you have. I should mention that if questions occur to you after this Q&A session, I'm going to put up at the next slide contact information for myself and for Mike Bernard, and you're welcome to send email to us, and we'll respond to your questions via email.
Hi, everybody.
So I'd like to introduce Mr. Michael Bernard, who's our academic program manager, and he's been writing down your questions as they've been typed in.
Hi, everybody. This is Mike Bernard. Thank you all for coming today. It's great to hear you all, I suppose, or see you at least online. Questions have gotten ahead of me, so I have some answers here, and we'll go as we can here. So give me a moment. Let me just get up to the first questions. Okay. First one, and I apologize in advance if I mispronounce your name, from Jetao, asking how many students we have. We have approximately 120 PhD students and 60 master's students. And Deepak is asking about the possibility of multiple advisors. And let's see, it is absolutely possible to have more than one advisor. Some of our students have more than one, both from mechanical engineering and another department. So that is quite possible for sure. Also, a person was asking if their background would have a negative effect because it's not necessarily mechanical engineering, and the answer is no. Our students have all kinds of backgrounds from everywhere, so we do encourage you to apply.
Well, and I want to just point out that Gianna's undergraduate degree is in physics,
Yep.
and Andrew's undergraduate degree was in electrical engineering.
Yeah, so neither of us had the background you would think to come into mechanical engineering, but obviously we both made it through, and it probably wasn't as bad as you're assuming it would be.
Yeah, and I did my undergraduate degree in mechanical engineering, and then I got my 2 masters and a PhD in electrical engineering, and ended up in the mechanical engineering department. So we're pretty interdisciplinary here.
All right. Great, thanks everybody. All right, somebody had mentioned they could not find the Fall 19 option in the graduate application system. We're going to be alerting the graduate admissions office to get that fixed. Second time I've heard it, so we definitely have to say something. Somebody else was stating specific interest in professors and had given their exam scores. So with that, if you have all right. Yeah, we encourage you to apply, and if you have interest in a specific professor, you have a space on the application to say, I would like to work with Professor so-and-so, so please use that option. Next person is asking if you need to mail a transcript to us. We ask that you upload your unofficial transcript with your application. If you're admitted and you accept admission at that point, then we will need the official transcript to be sent. And let's see. Yes, thank you. Another one, can you apply to more than one department in the same year? Yes, you can. You have to submit separate applications. So one to mechanical engineering, for example, and one to civil engineering or another department. Totally okay. You will pay separate application fees, though. I'll give you that heads up. All right. Another person's asking about, is there a limitation of length for a statement of purpose? There really isn't. My experience, I've seen students type about a page and a half. I wouldn't go super long, because if it gets too long, we might not want to read them as much, but still give us whatever you need to so we get to know you for real in your statements.
Yeah, and I think that what you want to focus on in your essays for application is what's attracting to you the program, what would you like to learn in our program that will enable you to be successful in your future career, and a little bit about how you've prepared yourself to be successful in our program.
All right. Next one asking is, where do letters of recommendation have to come from? Because the Johns Hopkins graduate application site says at least 2 academic professors. That would be really nice if you do that, because you want to have people who know you well enough and who can vouch for your ability to do a graduate program well to send recommendation letters for you, and most of the time they are going to be your academic professors. Occasionally you may have a research professor with whom you work who could vouch for you as well. So we're going to trust your judgment as to who you would like to have send your letters. Another person was asking about course requirements for the PhD and the structure of their master's degree compared to Hopkins. The structure of your master's degree doesn't have a specific effect on your application. if you've earned your master's degree, that's great. Whether that's through mostly thesis and a few courses or all courses. We have both options ourselves. So typically, a student will take anywhere from 10 to 16 courses post-bachelor's, whether they're taken with us at Hopkins or at a previous institution.
A question that often comes up, master's students will often ask, they'll say, well, I've taken 10 courses for a master's degree. If I enroll in the PhD program, in your PhD program, do I need to take an additional 12 courses for the PhD? And the answer is usually not, because usually people do their master's degree and their PhD degree in a similar area. And so the courses that you take towards your master's degree would count towards the PhD requirements, assuming that they're in an appropriate area. And so, and the next question is
interest in aeronautical or aerospace research and what classes are available here?
Yes, the answer is we have a number of faculty members who are working in the broadly speaking in the aerospace area. We teach both undergraduate and graduate courses in aerodynamics, mechanics of flight, fluid mechanics, and materials, all of which are important for aerospace. And we have faculty members who study fluid phenomena both in aerospace structures, but also in a variety of other applications, such as energy production for alternative energy production, and trying to understand how things like how insects fly and how birds fly.
All right. Another person was expressing concern about GPA and eligibility to apply at Hopkins. Again, we're going to ask you to trust your judgment on that. The GPA is not the only thing we look at in a graduate application. Of course, there are exam scores such as your GRE and TOEFL if you need to do a TOEFL. There's also your statement of purpose and the letters of recommendation. Sometimes students who have concerns about GPA might be offered admission based on really strong recommendation letters, and vice versa.
Another question was, do any mechanical engineering professors have a relationship with these Space Telescope Science Institute? The answer is yes, and we have a particularly strong connection with our undergraduate and master's design program. And each year, our undergraduate and master's students do design projects with astronomers at the Space Telescope Science Institute.
And also, we've just begun a master's design program this year where the master's students work in conjunction with the seniors, so you can get a really incredible experience here in design. It's a really fantastic thing to do. All right, I'm going to move on to the next questions. Somebody was asking about the GRE analytical writing requirements and the math and verbal scores and what their relationship is. Now, what I've seen typically is that the quantitative score is the one that's most competitive. That's the one where students score very high in our admissions. The analytical scores, well, we certainly would like for you to do well with that, but if you don't get a 6, and I think in all the years I've seen applications, I think 3 people have gotten a 6. Don't worry about that as much, but do as well as you can. Go ahead, Liz. Okay, so I've seen students with scores between 3 and 5.5 amongst our population, so I wouldn't be as worried about that, but definitely think about your quantitative, your math score. Verbal scores, again, also the separate verbal section, again, do well. You don't have to get a perfect score on that.
A student asked, do any mechanical engineering professors have a relationship with the Goddard Space Flight Center? This is the Goddard Space Flight Center is located between here and Washington, D.C. And the answer is, yeah, I do. And I can show you my NASA badge. I have a badge which will get me on the campus at Goddard Space Flight Center. The project that I've been doing with Goddard is with the Satellite Servicing Projects Division at Goddard. I've been doing this project for about the last 5 years. And what we're working on with them is technology for on-orbit telerobotic servicing of satellites. So the idea is that you launch a repair satellite which goes into low Earth orbit, and it docks with a satellite that needs to be repaired or refueled. Once it docks, then it uses robot arms that are remotely controlled by human operators on the ground to service the satellite, refuel it, and then send it on its way. And the project that I have is jointly with a computer science professor, Peter Katsantzidis. We've got several PhD students working on the project. And the really exciting thing about that project is NASA is going to be launching a a repair mission in 2020 called Restore L. And so if you Google Satellite Servicing Projects Division, you can read all about it. They're going to launch a repair satellite, and it's going to dock with a satellite called Landsat 7, which is a weather observing satellite that ran out of gas about 9 months ago. So it did its last Delta V burn 9 months ago, and it's out of gas. And if it doesn't get refueled in the next few years, it's going to fall out of the sky. So the idea is that on Restore L, this repair satellite is going to dock with Landsat 7, fill it full of hydrazine, and then it's going to be able to boost its orbit and live for another 20 years. Other faculty members who are involved with the Goddard Space Flight Center include KT Ramesh, who does mechanics of materials, and he's very actively involved with extreme materials and things like ballistic collisions, where what happens when an asteroid plows into a planet, and what happens to the materials that energetically interact in that case.
All right, this one's for our students here. It looks like faculty advisors are very involved personally with PhD candidates, and to you both, has that been consistent with your experience?
Yes, I would say.
This is Andrew speaking.
Hi, this is Andrew. Yes, they're very involved with, or Lewis at least is very involved with my research, and we have two standing meetings every week in which we meet for an hour twice a week to discuss my research. And whenever I have questions, I can just send him an email or show up to his office.
So Andrew's been helping me this week finish a grant proposal that we submitted about an hour and a half ago. And what's your next deadline, Andrew?
I have a deadline November 30th, getting a paper out. Right. I guess we both have that deadline.
Right. Andrew was Andrew was lead author at a conference called Robotic Systems Science, and his conference paper was invited to be submitted as a journal paper for one of the top robotics journals. And so we're going to finish that up by the end of the month. You like how I say we?
Yeah.
The royal we.
You get to proofread it.
John?
Yes, this is Gianna. I would say that the faculty are definitely involved, and it actually does depend on the advisor you choose. That's something important to consider when choosing the right advisor, is how much hands-on experience do you want with your advisor. So some people like to have a little bit more hands-off, that you have maybe every 2-week updates, or more hands-on where you can just come and knock on the door every few minutes. So I work with Kevin Hemker, and we have a little bit larger of a group, so we have bi-weekly individual meetings. We have weekly group meetings, so we all get to know what we do. We sit in offices with other students that aren't necessarily just in our labs, get to collaborate with them and kind of hear from what the other professors are doing with their students as well. So I definitely think you have a good relationship with your advisor.
All right, thank you. All right, the next question is, we mentioned that departments tend to collaborate with each other. How is this facilitated? Do PhD students work with multiple advisors? Yes, for sure. And I believe facilitation really is, it depends on the research group as to exactly what relationships they have with other research groups within Hopkins and in other places around the world. And so, I mean, I can speak from what I've seen. It happens quite a lot.
Yes, this is Lewis. Much of our work in the mechanical engineering department is very interdisciplinary. So we have several faculty members, gosh, at least 8, that work in mechanics and biology and medicine, and they collaborate with other faculty members in basic science departments such as biology, and they collaborate with MDs down at the School of Medicine. And so oftentimes, if you're doing interdisciplinary research, it takes an interdisciplinary advisor team in order to mentor that project. Same is true in robotics, broadly speaking, because robotics involves both mechanical engineering, electrical engineering, computer science, and experts in an application domain. So I work with oceanographers who want to discover new things in the ocean. They need my tools, and I need their motivation for building new tools.
All right, the next couple address financial aid. For master's students, the financial aid consists of some assistance with the health insurance costs. Unfortunately, the rest of it is the responsibility of the student. But for PhDs, PhDs do get what we call a full ride, which is the full tuition, coverage of health insurance, a one-time matriculation fee, and a really decent salary that Andrew mentioned a little earlier. And this is available both to American and international students at the PhD level.
And the PhD stipends are uniform for all PhD students, and it's
$31,212 this year.
Yep.
The value of the entire aid package, including the tuition and health insurance and such, is about $87,000 and change per year, 87,000 US dollars. Now, when it comes to master's students, don't despair. If you have ideas of becoming a PhD student, there are two ways you can do this. If you're a master's student with us, you can work with a professor to advance to the PhD program, and the moment that happens, you will get that same financial aid. And if you are someone who wants to get a PhD someday, I recommend that you apply for the for the PhD program immediately, because our PhD students, if they don't have a master's degree yet, they will earn a master's degree along the way to the PhD, but they'll have that PhD financial aid. So definitely think about that. Okay. Let's see. Somebody's asking about remote programs. We don't in our department immediately, but we do have a division called the Engineering for Professionals program.
Yes, we do. We do. Should I give a little bit more
Yes.
information about this? So what exactly is the question?
Okay, so do we offer remote programs?
Oh, okay. So we do offer online and part-time master's programs, again, through our Engineering for Professionals unit. And within that, you can learn more information about these programs if you visit the URL ep.jhu.edu. That takes you directly to our online and part-time programs. We have a master's program in mechanical engineering within that division. And I can't remember all of the focus areas. I know robotics is one. There's some similar focus areas there.
But this is Lewis. If you go to the master's information page in the Mechanical Engineering Department website, there's more information about our full-time programs. And in the full-time programs, students are in residence on campus, and they typically finish their master's degree in 1.5 or 2 years. But there's also a link to our part-time and distance learning program. Yep. It's called Engineering for Professionals. And almost all of the courses in the Engineering for Professionals program are done online. And so we have students from all over the world involved in the Engineering for Professionals master's program.
And I believe that the chair for mechanical engineering for the part-time programs is Jafar El-Awadi.
That's correct.
All right. Thank you. All right. So, somebody's asking about summer research programs at Johns Hopkins. When it comes to PhD students, pretty much do research throughout the year. So including the summer in particular, there is a lot of time in the summer where students will pretty much focus exclusively on research. Now, master students also have an option to do research. You can, if you go for the all-course option, you can choose master's graduate research course.
So also, students undergraduates often ask about research opportunities in the summer, and we have several research experience for undergraduate programs here in the School of Engineering, and we have one in robotics and several others. And probably the best way to get a list of the research experience for undergraduate summer programs would be to go to the NSF research experience for undergraduates site and filter by Johns Hopkins, and you'll get all of the REU programs that are here at Hopkins. I'm familiar with the robotics program that we've been running for almost 20 years now, but I know that there's about 6 others as well.
Okay. All right, next couple questions ask about GRE scores. There is no minimum GRE score for your application to be considered. Also, somebody mentioned getting a 5 out of 6 in the writing, and if that was good enough, that's pretty darn good, actually. You would not have to worry about retaking that part of the exam. So that's all good. Next question is about TOEFL. Somebody earning a master's degree in the U.S., would they have to submit the score when you apply for the PhD? No, you would be exempt. Let's see, how many students typically apply to the PhD program and how many are accepted? The acceptance rate varies from year to year. It depends on the number of open PhD positions that our professors need. So that could vary. The applicants for PhD programs, thinking from recent years without looking at numbers, probably between 250 and 300 total. And we've had anywhere from, in the last few years, from like 15 to 30 new PhD students join us. So you see the variation there.
And the next question is, a student was asking, how do you find a research advisor? Are they assigned to you? Do they drop out of the sky? How does that happen? Well, in graduate programs around the world, assignments to advisor occurs in one of two different ways. In some programs, a pool of PhD students is admitted, and they spend their first year kind of rotating around to different laboratories. And by the end of the first year, they should have worked out an arrangement with a potential faculty advisor where they want to work with a faculty member and the faculty member wants to mentor the student. That tends to occur in very large programs. So if you go to Georgia Tech or UCLA, then there'll be a pool admission. And then you basically have to figure out who you're going to work with as your primary advisor. In our program right now, we admit with a designated advisor, sometimes a designated set of advisors when that's appropriate. And so in your application, you should not only designate the area that you're interested in, so mechanics of materials or robotics, aerospace structures, nanotwin metals, and you should also indicate the faculty advisors, the mechanical engineering faculty that you think you'd be most interested in. And fortunately, in this day and age, there is the internet, and so every faculty advisor has a research group webpage with information on what they do, information about their current students. They all have Google Scholar profiles, so you can look at their papers that they've been publishing, both recently and in the past, and which ones are most cited. So do a little bit of research on the faculty members that you're interested in, and name them on the appropriate section of your application. There's a place in the Q&A section of the application to designate faculty you're interested in, and you can also include that information in your essay.
All right. Somebody else is asking again about their background being in a different place other than mechanical engineering, if it's acceptable to apply to mechanical engineering. Absolutely. Somebody mentioned applied math. And so that's certainly a possibility. Let's see. Criteria for PhD admissions, a lot of it is an individual review by the faculty. So each faculty member will be looking at applications where students have either expressed interest in that faculty member or are interested in that general research area in which the faculty member is conducting research. So it's really, it's almost an individual decision.
But in the presentation, we also covered what the basic sort of cutoff lines are for things like GRE scores and GPA and things like that. And so take a look at that information earlier in the presentation. And if you have any specific questions beyond that, you can contact Mr. Bernard or myself.
Okay, next one, somebody's asking about what's being done in the design field here, specifically product design.
We have, in our master's program, we've been expanding our design offerings, and we've recently created, this year for the first time, a master's design program. So it's a full year design program where students actually have a client and an external project, and they're divided up into a team, and each team has a different client and external project. In order to do the master's design program, you have to have some experience as an undergraduate doing design, and so they're very interesting projects. I know that there's one going on this year for Space Telescope Science Institute involving some sort of optical engineering for a space-based telescope.
Okay, next person's asking if we do research in robotics. Oh, yes. Apply now. It's fantastic here. There's so much going on that you don't want to miss out. It's just really amazing what's going on here in robotics generally. Yeah. Professor Whitcomb did discuss it some during the presentation.
So you've come to the right shop. A little over 10 years ago, I founded our robotics center. It's called the Laboratory for Computational Sensing and Robotics. And we're a group that has about, I think we have about 9 or 10 resident faculty and about 9 or 10 associated faculty who are on this campus or other campuses at Hopkins, other schools like the School of Medicine. And we work in a broad area of robotics research. We have, I think, about 45 master's students and probably about 50 or 60 PhD students working in robotics. The PhD students are all in disciplinary programs. They're in mechanical engineering, electrical engineering, computer science, or biomedical engineering. And so if you want to learn more about the broad program of robotics at Hopkins, just Google Hopkins Robotics, and you'll get to the website lcsr.jhu.edu for the Laboratory for Computational Sensing and Robotics. And there's a list there of all the faculty and with links to their web pages for their groups.
Okay, somebody's asking if it's necessary to contact a potential professor before application. Not necessary. Some students do it. It's okay to do so, but you may get an answer quickly from some. Some may not respond right away. It just depends on the number of inquiries you receive and if they are looking for PhD students. So I would say, why not? Go ahead. And I can help you out with any questions on that if you're looking for more specific information about a specific professor. So feel free to contact me. All right. Another person's asking about entrepreneurial resources.
Oh, yeah. So interestingly, in the last 5 or so years, we've had a number of startups from across the School of Engineering where faculty and graduate students, sometimes just graduate students without the faculty, take ideas that they've been working on as part of their research and spin out a company. And so, for example, the one that comes to the top of my mind, if you look at ClearGuide Medical, if you search for ClearGuide Medical, or if you search for Radio Robotics, those are two recent, one of them is a medical instruments spinoff, and Radio Robotics is a robotics spinoff that a recent PhD graduate of ours, Kel Garin, started. And they just got an amazing amount of capitalization, and they're going into volume production in a new robotic system that you actually program by teaching the robot the actions that you want it to do, and then it plays them back.
Can I add some additional information? So Hopkins really has an invested interest in encouraging student entrepreneurship. We've actually just recently built a really beautiful facility known as Fast Forward U that includes co-working spaces, maker spaces. There's grants that students can apply for kind of like all stages of exploring an idea and launching a company. And so there's a lot of really great resources that are available. Can I skip back to an earlier slide? Is that okay? All right, let me see if I can do this. Anyway, that's okay. Oh, this is on your presentation. We'll continue to answer questions, and I'll bring back up the slide that has the URL for the resources. Here we go. Yeah, so I'm just drawing your attention. There's here are the two links that I was discussing. Ventures.jhu.edu and entrepreneurship.jhu.edu has some additional information regarding entrepreneurship-related resources at Hopkins.
You're all asking a lot of great questions here. Okay, somebody asked about research portfolios and experience of incoming students. Some students have done quite a bit of research in their past time before coming to Hopkins. Some have not done as much, but if you want research, this is the place to come.
How rigid is the undergraduate GPA criteria for PhD? Do students with a GPA around 3 and good research experience generally get in? Doubtful. You need to have a good undergraduate GPA. We're particularly concerned with your GPA associated with physics, math, and engineering. Next question is.
Yeah, we're going to do a couple more questions and we have to wrap up. So what we're going to do, for any questions that we don't get to, we'll follow up with you directly with your information. You are also welcome to contact me, again, Mike Bernard at mike.bernard@jhu.edu, and I can answer your questions. So let's see. PhD advisors are typically established upon admission. So when a PhD student is offered admission, the advisor is already listed in that admission. For master students, advisors are established over the summer just before matriculation begins. Let's see. We'll make this one the last question because it looks like a great question here, and I'm going to throw it to the entire floor. A student is looking at Hopkins in addition to other schools. What makes Hopkins better than other programs in your view?
Well, this is Lewis. I'm biased. I think that we've got one of the best robotics programs in the world, and certainly one of the top robotics programs in the United States. and we have a fantastic robotics center which has faculty members and students from all sorts of different departments, all of whom are collaborating in robotics research and education.
What impresses me about Hopkins is we're relatively small compared to a lot of the larger schools around the world, like state schools and so forth. And that collaboration that Professor Whitcomb mentioned also fosters excellent relationships around. We are a place that we want you to do well. You may have heard that there are some schools that try to get rid of their lowest dead weight or lowest performing people right away. We're not like that at all. We all stand by each other. We help each other out. If somebody's struggling, we help them as best we can. We celebrate our successes together. This is a place that you will find people of world renown, and you'll realize that we're all humans and that we can all get along very well.
And I want to encourage Gianna to say something, because I know that you've been involved in a lot of interdisciplinary research with a variety of different organizations.
Yes, this is Gianna. Definitely the reason that Hopkins won me over for sure is the interdisciplinary nature of Hopkins in general. I would say that almost no one does just one thing here. You have to kind of dabble in a few different disciplines. So whether you work across campus or other institutions, right? So no one school can have everything. So there's definitely been things that I needed tool-wise. And I've been able to go to other government institutions or industry places to work with them. And that's been great. It built my relationship with the industry as well as government and national labs and things like that. As well as, I think I saw someone later, I've personally had the opportunity to do a summer internship with GE Global Research while I've been here as part of my PhD. So that's something that obviously you have to talk with your advisor about, but that was a great opportunity for me to just try something new while still continuing my PhD and working in that field.
Andrew, do you have anything to add?
I guess for me personally, I'm especially interested in like ocean research, and at Hopkins we have a close collaboration with, I guess, interdisciplinary fields. So I do computer science, electrical engineering, mechanical engineering, and we also collaborate closely with the Woods Hole Oceanographic Institution up in Massachusetts. So through Hopkins, I've been able to make a lot of contacts there and create new colleagues up in Woods Hole.
Yep. Andrew and I taught a short course in the robot operating system at Woods Hole last fall. It was a compressed 3-day course. It was a blast to teach. So, all right, our time is up. We're going to wrap up this question and answer session. Thank you, everybody. We didn't get a chance to answer all the questions. I apologize. And you're welcome to email questions to Mr. Bernard and me. I'd like to thank our producer, Cheryl Williams, and Mike Bernard, and Gianna and Andrew for spending time on this web information session. So thank you all. You were fantastic. And please send us via email any questions that we didn't get to.
Yeah, we'll be chatting soon.
Thanks, everybody. Bye-bye.
Bye.